Okay, the final question. I'm not going to do the challenge questions. I will mark those if you've done them. Final question was question 19. It's a shame I didn't do 20 questions, but still. Question 19. And question 19 asked us to write a subroutine that was true if a certain number is prime or false otherwise. So if I said to you, is the number prime? You'd say, well, it depends on the number, and therefore the number is the parameter to the function. So def is prime. So notice again, I'm calling my function is prime, indicating to people who use my function that it is a Boolean function. And it's going to take in a certain number and determine whether or not it's prime. How am I going to do that? Right, let's just switch over and have a think how we might do that. Let's go back to just sort of some space over here for us to write on. Now, let's do an example. If I said to you, is the number 20 prime? Well, you might know straight away that 20 isn't prime because remember, a prime number is one that cannot be divided into different factors other than itself and 1. So I know that I can divide 20 into 4 and 5 because 4 times 5 is 20. So prime is not prime. So it's definitely not prime. We know that by just doing this in our heads, if you like. It becomes a lot more difficult for us if I asked you whether 4,123 is prime. Suddenly it becomes a lot more difficult. And we have to go through an algorithm to calculate whether it's prime or not. So how do I do that? Let's go back to our simple number 20. What I want to do is I want to check to see whether 20 has got any factors. So the first step, if you like, step 1 is test whether 20 has any factors other than 1 or 20 itself. Okay, in other words, if 2 divides into 20, it's not prime. If 3 divides into 20, it's not prime. 4 divides into 20, it's not prime, etc. Okay, and that's the same for any of these. So notice what I want to do is I want to test all of the integers from 2 up to 1 less than the number itself. So if we've got 20, I want to test 2 to 19. And if any of those divide exactly into this, then it's not prime. Okay, so step 2 is I want to go through each number from 2 up to whatever number we've got, which we're calling number, minus 1. If that number, or any of those numbers, divide exactly into 20, then 20 is not prime. Okay, let's do another example to show you what we mean. Let's take a number 37. Now you might know whether or not 37 is prime. That's fine. It isn't prime, but sorry, it is prime. But let's try and figure it out. So we're going to start at 2, and we're going to say, does the 2 go into 37? No. Okay, so let's try the next one. 3. Does 3 go into 37? No, not exactly. Does 4 go into 37? No, not exactly. 5? No, not exactly. 6? No, not exactly. 7? No, not exactly. 8? No, not exactly. 9? No, not exactly. I'm going to keep going all the way up to 36. Why do I stop at 36? Well, 37 definitely does divide into 37. So I don't want to include that 37. because that will always be the case, that 37 divides into 37, or 20 divides into 20, or 60 divides into 60. So I want to check every single possibility here until such time till I get to a number that divides exactly. So let's take another number that is prime. So let's take 21. Sorry, not that is non-prime, because 3 7s are 21. Let's take 23. So I'm going to start at 2, and I say, does 2 divide into 23? No, I wanted a non-prime, so, a prime number. So let's do 22. We know 22 is not prime because 2 11s are 22. So I'm going to check 2. Does 2 go into 22? Yes, it does. It goes in 11 times. So immediately I know that this is not prime because 2 divides into 22. So I can stop there and go, no, it's not prime, return false, not prime. Let's try a different number. Let's say I've got 25. So I start at 2. I say, does 2 go into 25 exactly? No. Does 3 go into 25 exactly? No. Does 4 go into 25 exactly? No. Does 5 go into 25 exactly? Yes, it does. It does, and therefore 25 isn't prime. So it's not prime because we've got this number that divides exactly. So the next question is how do I decide in programming terms whether a number divides exactly? Well, we did that in class before. We say that if the number 25 in this case, or in general number that we're trying to determine whether it's prime or not, if that percent, this value, whatever this value is, let's call that the test number, if that's naught, then it divides exactly. Okay, so that's this sort of idea of this modulo arithmetic. So remember, this is the percent is the remainder. Okay, so 25% number is the remainder of 25 divided by number. Okay, so let's go back to code. It's not easy, this, necessarily. So what we're going to do, we want to set up a loop that goes from 2 all the way up to number minus 1. I'm going to test each number from 2, 3, 4, all the way up to number minus 1. If any of those tests produce a factor of number, then not prime. If we've tested everything, if we've gone through every single possibility, and we realize that none of them divide exactly, then we know that it's prime. We've tested every single possibility. All right, okay, so here we go. Here's our loop. We're going to go 4. Let's call this test number. So we're going to test each number, call it test number, in the range, and we're going to go from 2 up to, the last one we want is number minus 1. So we always have one more than that. So this is going to be number. Okay, so in other words, if number was 5, this would do 2, 3, and 4. Remember, it's always one less than that. And we want to go to one less than number. Okay, so we're going to say if the test number percent number is 0, then we know that it's not prime. So we're going to return false. Okay, since it divides exactly, the number is not prime. So we return false. If we've tried every single combination, so if we get here, we know we have tried everything. All the numbers, 2, 3, all the way up to number minus 1. And hence, we know we have a prime. We're going to return true. Okay, let's test it. Okay, so we're going to say print is prime 2. Let's try 2. Okay. Now 2 is a prime number, right? True. Okay, so far so good. 3. 3 is a prime number. We're expecting true. Yes. 4. 4 is a prime. Oh, 4 is not a prime number. What's going on here? We are expecting. Yeah, that seems to be okay. So what's going on here? Let's see. Let's put a breakpoint in here. This happens a lot, by the way, when people write code, something doesn't quite work, we test it out, doesn't quite work, you put a breakpoint in, we go through as we bit by bit. So here we go. We've got test number is going to start off at 2. So it starts off at 2 and it's going to go up to number up to one less than this, the 3. So it starts off at 2. Is 2% number? This is the wrong way round. 2% number. This should be number percent 2. Because what we're trying to do is we're taking our number, like 20, and we wanted to see whether it divides exactly with this test number. So that's what's wrong. So this should be number. It should be test number. If you go back over here, that's what we said over here. Test number was there. Number percent test number. Number percent test number. Should have realized that we'd already worked out the order. Let's try it again. So let's run it this time. False. Okay, 4 is not prime. No, it isn't. It's 2 times 2, so it's definitely not prime. So let's rather than testing one by one, let's do a little for loop here so that we can test this. So let's go for I in range. Let's go from 1 up to 100. I'm going to print I and whether or not it's prime or not. Is prime I. So we're going to test 1, 2, 3, 4, 5, 6, 7, all the way up to 100. And we're going to print whether or not the number is prime or not. So let's run that. So here we go. This will be a lot easier. 1 is prime. Interesting. We'll come back to that in a minute. So I did that on purpose because I knew I hadn't catered for the fact that number should at least be 2. Otherwise, it's not prime. So 2 is prime, yes. 3 is prime, yes. 4 is prime, is not prime. That's good. 5 is prime, which it is. 6 is not prime. It's 3 times 2. 7 is prime, correct. 8 is not prime. It's 2 times 4, for instance. 9 is not prime. It's 3 times 3. 10 is not prime. It's 2 times 5. 11 is prime. Seems to be working. Let's try one more. 37. Yes, that is prime. 38. No, that's 2 19s at 38. So it seems to be working, except for when we supply 1. So we're going to say if the number is less than 2, we're going to return false. That takes care of that for us. We know now that any number less than 2 is definitely not prime, and therefore, there we go. There is another question about what happens with negative numbers. Can we have negative numbers being prime? Do they have factors? Yes, they do. So we're just going to deal with positive numbers at the moment. But at least now we've got the correct result of 1 being non-prime, 2 being prime, 3 being prime, 4 being non-prime.